All right, welcome to 11.5's notes completion. Volume of prisms and cylinders. So we get into the wacky world of volume here, and you'll see the shapes start repeating what they want you to know for each of them. But first is the introduction to volume. Volume of a solid is the number of cubic units. So we had length, width, now we have height. And Cavalieri's principle states that if two solids have the same height and the same cross-sectional area at every level, then they have the same volume. So that's kind of how I want you guys to think about it. Just find the area of your base and then stack it all on top of each other until you get to a certain height, filling it up, creating a volume. Our two volumes today, prisms and cylinders. As you can see here, it's the same formula, BH, BH, where big B is the area of the base, and of course H is the height of the prism, or cylinder in this case. But for all cylinders, the base is a circle, so it's going to have us use pi r squared h. So pi r squared is the area of the circle. Stack it up until you get to the desired height, filling it up. Now, even if it's oblique, this is what's considered a right cylinder or a right prism. And when it's leaning, like leaning tower or Pisa type stuff, those are called oblique solids. All right, first one, here we have a triangular prism. And again, the base of the prism is the triangle, and you stack it up with the height. So even if this thing is positioned like this, the height is still the distance between the bases, right? So what you've got to do, the volume would equal the area of the base times the height, and the area of the base is just 1/2. Since it's a right triangle, your base and height are just 3 and 4, interchangeable of course. And then the height of the entire prism is 2. And again, it's a little tricky because you're talking about different, like height. One's height of a triangle, one's height of the prism. So be careful, make sure you're typing in the proper things. And you get 12, and again, it's cubic units now, so 12 cubic centimeters. Second one is practice with a cylinder, and this one is oblique, but that's okay. The height of it is 7. So all we're looking for here now, I tend to write the formula out, and again, you'll be given all these formulas on the quiz. But I tend to write the formula out first and then just plug in what you know. So there's big B, pi r squared is the area of the base, then the height is 7, of course. Clean up my parentheses a little bit. And when you multiply that out, it doesn't ask for which method. So 16 times 7 is 112. So you can have 112 pi's, or you can multiply it out to get approximately 351.9 cubic centimeters. All right, next we have density. Ooh, density is the amount of matter an object has in a given unit of volume. So, at volume, so it's going to relate to this section for us. And it's a chemistry problem a lot of times too, you see in science class, density. So how dense is something? Where you take its mass and you divide it by how much space it occupies, aka the volume. Now, for this particular example 3 problem, what happens is they're going to ask you to convert a lot, because the diagram shows dimensions of a standard gold bar at Fort Knox. Gold has a density of 19.3 grams per cubic centimeter. But look at our units, they're all in inches. So we've got to convert, that's why they give you this. So to convert, you just take 7 inches and multiply by the conversion rate. And you want the inches to cross out, so you put inches on the bottom. Multiplying this together and you get 17.78 centimeters. So that's how you essentially switch. And you're going to want to do it with all of them. 9.2, and this one ends up being 4.45 centimeters. So change them all to centimeters, and then you can find the volume of one gold bar. So area of the base times the height is just all 3 of these things multiplied together. So 17.78, 4.45, and 9.2, and your volume is 727.9. Then you can use the formula, which is D equals M over V. So the D is 19.3. Mass is what we're looking for, and volume we just found, 727.9. So multiply both sides by 727.9, and the mass of this thing, one gold bar, is about 14,048 grams. All right, take a sec, pause the video here, and complete the monitoring progress question. All right, welcome back. Switching all these first. That gives us 81.28 centimeters. And this gives us 60.96 centimeters using the same conversion, multiplying them by 2.54. And so then the volume of this thing is, using pi, 60.96 squared times 81.28. Your volume, then plug that in. Let's see, so my volume is 948,906.6. So my formula, D equals M over V. Density is 2.3, so 2.3 equals mass over 948,906.6. So the mass of this concrete cylinder, 2182485 approximately, and that is in grams. All right, moving along. Next we have to back solve some stuff. So in this case, we want to look for the height. We know the volume and we know the area of the base. So our formula says area of the base times the height. The volume is 72. The area of the base, 6 by 4, so my big B is 24. So I've got 24, then the height is what I'm after. So just divide both sides by 24. And for this volume, you should have a height of 3 feet. So you got to be able to back solve for an element inside the equation as well. Moving along, example 5. So same concept here. You're building a 6-foot tall dresser. You want the volume to be 36. What should the area of the base be? So we know the height, 6 foot tall. So volume equals big B times H. So 36 equals big B times 6. Divide both sides by 6. And the area of my base should be 6. So now give a possible length and width. You can break it up. 2 by 3, 6 by 1, 4 by 1.5, etc. All right, next, very important concept here, similar solids. We had similar shapes before, like say for instance we had similar rectangles. So let's just say I got a 2 by 3, this would be a 4 by 6. I double both sides. All right, so the scale factor is 2 to 1. Well, the area, 2 by 3, this one would be 6, this one would be 24. The area doesn't double, the area quadruples. Well, when we look at volume, it's going to be the next dimension. So if my scale factor is 2 to 1, my area ratio would be 4 to 1, and my volume ratio would be 8 to 1. So the volumes on this thing, if say I made it a prism, and let's say I went by 4, and then this one would go by 8. So then when I took 4 times 2 times 3, that's 8 times smaller than 8 times 4 times 6. So if that's a little confusing, example 6 should clear things up for you. Let's check out what we got here. Cylinders A and B are similar. Find the volume of this second one. So we're looking for the volume. All right. So now how in the world are we going to find this? Because we don't have the height of this thing. But we know the volume and we have a connection. So the scale factor is how you're going to want to start this one. Your scale factor is 3 to 6 or 1 to 2. So then you take that and you cube it to get how your volumes relate. You've got to cube it because you're missing a volume. So you want to use the volume ratio. All right? So now you can use that to set a proportion up. You know the small volume, so put that on top, and you're missing the larger one. So when you cross multiply, 45 times 8 is 360 pies. So that's the volume of your larger. And just make it make sense. Your side doubles, well, there's 3 dimensions, so you got to double, double, double. So you got to times it by 8 to get the volume. It's not just going to double, it's going to change relatively. All right, let's pause the video here and try this one. All right, back again. So we should have, let's see, a scale factor of 1 to 4. Well, let me back it on up so you see where that's coming from. Your scale factor of 3 to 12, that's your link, which is 1 to 4. So then, of course, we cube that. So my volume ratio is going to be 1 to 64. So now I use 1 over 64 as your ratio in a proportion solving for the missing. We're missing the small volume here, so we put the variable on top. So I go small over big, 1536. And when you cross multiply on this one, divide by 64, and you get 24. And this is meters cubed when you solve for big. All right, and wrapping things up today is what's called a composite solid. When you have a couple things happening together, whether they're on top of each other where you're adding them, or drilling a hole out where you're subtracting them like we are here. So we have a triangular prism with a square prism hollowed out of the center of it. So my game plan is triangular prism minus the square prism. So now we got to do a little bit of work here. So the triangular prism, we got base times height, and then we're going to subtract this base times height. This is of the triangle, this is of the square. So I got to find the area of the triangular base, and all I know is it's a 10, 10, 10. So I drop the height down, cut that in half. Oh, then it's a 60, 30, 60, 90. So if that's 5, then my height is 5 roots of 3. If you forget that, just put it in as tangent 30 equals 5 over the height, and then you can solve it that way. But I'm just going to use my shortcut 30, 60, 90 rules. So for this one, the area of the base is 1/2, 10, then my height was 5 roots of 3. The height of this thing was right here, 6. Subtracting the area of the square, 3 by 3. So this one is 3 by 3. And then how tall is it? It's also 6. And just remember, your height is your distance between your bases. All right, so this ends up being 150 roots of 3, but you can just put all this in your calculator. I'm just taking it down further and round it 205.8 cubic feet. All right, guys, that's a wrap on 11.5. Peace.